Okay, so this is the first lesson on acids and bases. We ended up solutions with a quiz, and now we will start with the acids and bases, which is the second part of this kind of unit. And on the very first thing, we will talk about properties of acid. On this lesson, we'll talk about properties of acids and properties of bases, and then we will move to what is hydronium ion. So now for what we have discussed for as long as we have been in chemistry, we know some of the acid properties and some of the basis properties. So we can say that based on what we know from the previous chemistry classes, we know that acids are sour taste, and they have a pH that is greater than 7. They turn litmus into blue, litmus red into blue. And they react with metals to form a salt and water, and then they are ionized in water. We talked about this in dissociation and ionization. And they are electrolytes, so they are able to conduct electricity. Light. When we are talking about bases, properties of bases, they are bitter in taste. They have a pH that is less than 7. Litmus paper is turned blue. They do not react with metals. They dissociate in water. And they are electrolyte as well. Okay. Now, if we talk about naming acids, and this is mostly review from Science 10, when we have like what is happening is that when the negative ion, which is called anion, is combined with hydrogen, that is the positive ion, and then what is happening is form an acid. Okay, now different non-metals or negative ions are combined with the hydrogen, and on this case what is happening is we are taking the hydro part, that is the hydrogen, and then taking the root of the anion and adding IC. So for chloride, what we will do, the root of chloride is chlor, and the name of the acid, when you name it will be hydrochloric acid. Okay, so the root will be, the name of the acid will be hydro, to identify that you are dealing with the positive hydrogen, the ion, and then the root of the anion, adding IC, hydrochloric acid. Or when we have polyatomic, like chlorate or perchlorate, then what do is we take again the root and then we make it IC. And when the polyatomic ends with ATE, it's in the name of the acid is converted into IC. And when the anion ends with ITE, then the name of the acid is with OUS. So this case will be chloric acid without that hydro part, and on this case will be chlorous acid. Okay, so let's see some examples in which we are working with naming. So on the first one we have HBr. So that means that the proper name will be hydrobromic acid. Okay, why is this so? Because bromine is an element, so the root of bromine is brom, and then in order to identify that we are dealing with acid, then we add hydro, so hydrobromic acid. On the second case, we have SO4 as cation. So what do we do? Sorry, as anion. As anion, we have SO4. So now which is a polyatomic. And when we see the polyatomic table, SO4, the name for SO4 is sulfate. So SO4 is sulfate. So ends up to be the second option that we said there. So now the name of the acid will be just the root of it without the hydro. So sulfur, okay, sulfuric acid. For SO3, the name of it is sulfite. So now what we do is we convert ITE into OUS, and then we add acid. So it will be sulfurous acid. Now that we know carbonic acid, so we will go and look at the periodic table, and then we will see that carbonic means that we are looking for something that ends with ATA, so will be carbonate, and the formula will be H2CO3. On the case of hydroiodic acid, so hydro means that you are dealing with an element. Iod means that you are dealing with iodine, and because the root of iodine is IOD, and this is what we do. We add the IC and then the word acid on it. So this will be HI. And for nitrous acid. So the acid ends with OUS, which means that the anion will end with ITE. So, and we are dealing with nitrite. So will be NO3, NO2, sorry, NO2, nitrite, NO2. So then the acid will be HNO2. Okay. When we are talking about the naming the base, what do we have to keep in mind is that the base always has that OH as a part of the formula, of the chemical formula, which is the hydroxide. So yeah, it's OH minus is the hydroxide, and what it is always is a metal with the hydroxide. Now, even when we name the base, we name it as name of the metal plus the word hydroxide. So when we have, let's suppose, KOH, then the name of this base will be potassium hydroxide. Or when we have aluminum hydroxide, so bases are easy to label versus acids are, we have to keep in mind when we have the acid name, then we have to see, is it an element with hydrogen, or is it a polyatomic ion? And if it is a polyatomic ion and the name of the acid ends with IC, then the name of the polyatomic will end with ATE. And if the name of the acid, or vice versa, and if the name of the acid ends with OUS, then the name of anion will end with, polyatomic will end with ITE. Okay, so now when we have this H plus into water, which pretty much is a proton. So now we know that the hydrogen has the number of electrons in hydrogen is equal to 1. Number of protons in hydrogen is equal to 1. And we don't have any neutron in the molecule of the hydrogen. So now if hydrogen is becoming an ion, H plus, then what is happening is that it is just the proton left into the molecule of the, or into the atom of the hydrogen. Okay, so now when what is happening, this proton, which is in water now, because it is charged 1, and because of the nature that the water molecule has, will be attached to the water molecule to create that is known as the hydronium. So the hydronium, what it is actually a water molecule with an hydrogen proton or hydrogen ion attached in it. Okay, so hydronium, what it is actually is you can call it a hydrated proton. Okay. which is water molecule with an extra hydrogen ion. So now, water is considered to be a non-electrolyte before. Water was considered to be non-electrolyte. However, now we see that with very sensitive equipment, we are able to see that water actually is slightly conductive. Now, why do you think that water is slightly conductive? Because water slightly ionizes, okay? Because water slightly ionizes. Slightly ionizes. And when two water molecules collided, they produce that is known as the hydronium acid and hydroxide, which is hydronium and hydroxide. When two water molecules collide, they produce hydronium, which is an acid, and hydroxide, which is a base. Okay, so now two water molecules, H2O plus H2O, they form the hydronium, H3, H3O plus, which is an acid, and a hydroxide, OH minus. So this one is an acid, gives the qualities of an acid, and the hydroxide gives the qualities of a base. Okay. All aqueous solution will have some hydroxide and some hydroxide and some hydronium. Concentration or hydrogen ion. Okay, so this is in terms of the hydronium. What do you have to keep in mind again is that what is happening with that H plus is, since it is charged entity, and now we know the qualities that the water molecule has in terms of the being polar and having a shape, as we said and discussed in bonding unit, having a bent shape, then being polar. And then we have the hydrogen and oxygen, they have different charges. So then this creates the water molecule to be attracting different charges. So now what will happen, this proton that is free in water is attached with a water molecule, creating the hydronium ion. And hydronium ion is just water plus a proton. This is the first part of lesson 3, and we'll continue with the other parts right now.